What's going on, everybody? Zane here, back with another video. For this one, we're going to go over question number 2 on Leetcode called add two numbers. So this one is a linked list problem, and it is a medium problem, and I'm going to go over some of the tips/tricks that I've learned in my linked list studying, and hopefully things will make sense, so let's get into it. So we're given two non-empty linked lists. First off, we're given two non-empty. So right off the bat, I don't have to account for any edge cases. Like if L1 equals null and L2 equals null, then just return null. I don't have to do that in this case. So that's just my kind of trigger. The digits here are stored in reverse order, which is great because when we're dealing with carries, we're going to be able to use this property to our advantage. And each node contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that two numbers do not contain any leading zeros except the number 0 itself. Okay. So here, for example, here we have 2, 4, 3, and then 5, 6, 4. We'll add 5 and 2. That'll be 7. Usually we're, of course, going to go from right to left, but since we're in reverse order, we're going to go from left to right. So we'll do 5 plus 2, 7. 6 plus 4 is 10. So we'll do like a mod of that value of this sum here. And whatever the mod is, we'll put that down here, and then we'll bring the carry over. So we'll do 4 plus 3, 7 plus the carry, which is 8. Okay. So let's get into the code here. For me personally, I was able to understand this better with the code. And what I'm about to do is typically what I do for most of these linked list problems, which is let's first create two linked list nodes. One of them is going to be our answer. It's going to be a new list node. And in here, we can put some dummy value, but I'm not going to do that because it really doesn't matter. I can put 2, I could put -1, I could put 251, it doesn't matter. So just create a list node called answer, and we'll create another list node, and we'll call that current, which will refer to our answer. This is just standard list node kind of process. At least for me, what I've seen so far in my video or in my studying, this is what seems to be like your typical beginning of a linked list problem. You create an answer variable, you create a current variable that refers to your answer, and then you'll do the classic while loop where it says while L1 does not equal null or L2 does not equal null, then continue on. And the reason we're doing this is because one of them could be null. So if we do a check for like AND, that means that no matter what, we're forcing a check here to make sure both of them are not null. But we could have one being null. So let's do OR. So right here, this is like the classic linked list beginning, at least from what I've seen. So just forgive me if you haven't seen this, but this is what works for me. So anyway, while L1 does not equal null or L2 does not equal null. So we're basically checking to make sure, okay, is one of them at least not null. So now what we could do is we can check to see if L1 is null. That means that L2 has a value. So L2 here, L2 must have a value. So L1 is null, so L2 must have a value because of our initial check here. So let's first create a variable for our sum, because that's what we're going to be doing. And maybe we'll create another variable for our carry. I'm going to create this now only because I've gone through the problem, but if you were to go through this problem and not even deal with the carry, you might be able to actually solve the few base cases, but then the carry is required. So when you're going through the problem yourself, you'll notice that, hey, you're encountering issues, and you'll notice, oh, what if there's a value that's greater than 9? That's when the carry will come in. So don't worry about like, oh, where did he get carry from? It's of course from me doing my research and playing around with the problem. So if you were to do that, you would also stumble upon you needing a carry. So don't get discouraged. So if L1 is equal to null, that means that L2 is a value. So what we can do now is we'll say that the sum is going to equal whatever the value of L2 is plus whatever our carry is. Then once we've accounted for that value, we can just say L2 equals L2.next. And what this is doing right here is just saying, okay, we've accounted for that value, so now move to the next value in that list node. Now, otherwise, if L2 is null, that means that L1 has a value. So we'll say kind of like the opposite up there, we'll say sum is going to be equal to L1.val plus carry, and then move L1 over. And then our last else here is going to be, okay, now we've gotten to a point where L1 does not equal null and L2 does not equal null. That means that our sum can just be both L1's value plus L2's value plus the carry. And then what we need to do is move both over. Now that we've moved both over and we're at the bottom of our while loop, now we need to think about our carries. So in our first iteration here, we're going to get to a point where, let's just use this as an example. If we're using L1 does not equal null or L2 does not equal null, that means that both of these values exist. In this example, it does exist. So in our first iteration, our program will jump straight to here. So now our sum is going to be whatever L1's value is, which is 2, and L2's value, which is 5, so that's going to be 7. And since in our first iteration we set carry to 0, well, our carry is just going to be 0. So our sum technically is going to be 7 as of right now. And then we move it over. But now we need to account for that carry. So what we could do is we'll use our mod and division operators. So I'm going to create some dummy value. And this dummy value is going to be for our list node. I know this is going to be a longer name. This probably is not the best name to use either, but just for the purposes of explanation, I'm going to say the dummy value for our list node is going to equal whatever the value of our sum is modded by 10. Now think about mod 10. Mod 10 gives us the far right number. Now if we were to do this on our sum, our dummy for our list node is going to be 7. Then what we could do is, once we've gotten that, we need to also create our carry. So our carry is just going to be our value of our sum divided by 10. So if we were to take, let's say is the sum, which is 7, divide that by 10, that'll give us 0 because there is nothing to carry over. It's going to be a decimal. So now we have some dummy value for our list node, which is the far right value. If our number was a 10, that means if we do 10 modded by 10, that'll be 0, which is great because in this case, 6 and 4 is 10. So our dummy value for our list node is going to be 0. And that's why 10 mod 10 is equal to 0. That's going to be the dummy value we used for our list node. And that's why we have a 0 here. So this value is technically, this mod 10 value off of our sum is what we use for our actual answer. Then the carry is just going to be whatever is remaining over from 10. Or in this case, if we do the division of it and there's still leftover, then that's going to be our carry. So now what we can do here is, once we've gotten that value, we can say that the current dot next is going to equal a new list node. So we'll create a new list node at our next value on our current dot next, and that'll just be the dummy value for our list node. And then what we can do at the final step here is we've accounted for our dummy value, we've accounted for our carry, and we've added our value here. So now we can just say current equals current dot next. Now we're still in the while loop. So once we've gotten all of that done, we can jump out of this while loop. And now we can say that if the carry is equal to 1, so if there is a carry, then what we need to do is we need to say that, okay, we need to account for some new list node that will be just a value of 1 because our carry is 1. So we'll say that current equals, current.next equals a new list node of just 1 Otherwise, return, and now we're at the final result. We'll just return answer dot next. And the reason we're doing dot next is because we initialized a new list node, but with no value. And even if we did have a value here, like 1, 2, 3, we want the next value. We don't care about the dummy value, so we're going to the next value. So let's run this. Let's see what we get. Good to go. So I think here with the best course of action, and yeah, you can see I've tried this a few times, and this was a little bit tough, even though it says it's a medium problem. But what we're doing here is we're creating two list nodes. We create a sum and a carry variable. Now making sure that one of them at least is not null. Then we'll check to see if L1 is null. Okay, use L2 as the sum and move it to the next value. Do the same for the other side. If both of them are not null, then okay, use both. Now here is just probably the most, I'm not sure if it's the most complicated part, but for me it was, we created some dummy value for our list node, which is just going to be the sum modded by 10. That will be what we use for our answers list node regardless. Then our carry is going to be whatever the sum is divided by 10. And we'll set our next value in our current list node to be whatever that dummy value is, because that'll always be the value. And then we move our current to the next value. And at the very end, we'll say that if the carry is equal to 1, okay, then just create a new list node at that value at current.next with the value of 1. Then return answer.next. Anyways, guys, that's it for this one. If you have any questions, comments, feedback, or if I didn't make anything clear, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.